Okay, so 4.1, we start the quadrilaterals by just talking about parallelograms. Okay, so we're going to hit the right side of that diagram. Okay, so only parallelograms, because parallelograms have 6 different properties that you have to know. Okay, so a quadrilateral with 2 pairs of parallel sides is a parallelogram. To write the name of a parallelogram, you use the symbol that looks like a parallelogram, or you can just write parallelogram. So if we were naming this, we'd make a little parallelogram shape. Mine's wonky. And you would name it parallelogram ABCD. Okay, so there's lots of properties, lots of postulates and different things that go along with parallelograms. The first one, if a quadrilateral, so a 4-sided figure, is a parallelogram, then its opposite sides are congruent. So you've got parallel lines on here. So the first property says if you've got a parallelogram, you can state the opposite sides are congruent. So you can code like that, and we can say AB is congruent to BC, and BC is congruent to AB. So if you know you have a parallelogram by the markings, you know that the opposite sides are congruent. That's property number 1. Okay. Property number 2. Theorem states if a quadrilateral is a parallelogram, then its opposite angles are congruent. So we have the coding for a parallelogram, then we can state like the blue angles are congruent, opposite of each other, red angles are congruent. So angle A is congruent to angle C. And angle B is congruent to angle B. So that's property number 2. All right, property number 3. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So consecutive are supplementary. So what that means, next to each other, we take the measure of angle A and an angle next to it, so the measure of angle B, it's supplementary, so it's going to add up to 180. And we can do that all the way around the parallelogram. So then I can say angle B plus angle C should also equal 180. And keep going. So measure of angle C plus measure of angle D should also equal 180. And then measure of angle D plus measure of angle A should also equal 180. So each set of consecutive angles should add up to 180. All right, that's property number 3. Property number 4. If a quadrilateral is a parallelogram, then its diagonals bisect each other. What does that mean to bisect? We've used that word a lot in this class. Cuts it in half. Good. So diagonals are the segments that go through diagonally your parallelogram. And if they are cut in half, that means these two are congruent. So BZ is congruent to DZ. And then vice versa. We can say AC is also cut in half. So we can put 2 tick marks on that diagonal. So we can say AZ is congruent to CZ. And that's property 4. Any questions? Okay. Let's try try and use some of the properties. So in parallelograms CDEF, we know DE is 74. We know DG is 31. And we know angle FCD is 42. So it tells you you have a parallelogram. So knowing we have a parallelogram, we can apply all four of the properties that we have learned thus far. So the first thing it asks us for is CF. What do we know about CF? Good. CF is opposite of DE, and in a parallelogram, opposite sides are congruent. Everybody good there? Okay, DF. What do we know about DF? Okay, so DF is the whole diagonal, right? So 31 is going to be congruent on both sides, so you can add those to be 62. Because it was bisected. And then lastly, measure of angle EFC. So EFC is this angle here. What do we know about that angle?
Because it's double 180.
Good. It's supplementary with the 42 next to it. So 180 minus 42 is how much? 138. Make sure to put the degrees on there. Any questions? Okay, very similar problem with a basketball goal here. You guys try this one. Label it, figure out the three pieces. Go. Alright. First thing you needed to find was KN. Who wants to tell me what they found for KN?
28.
28. Everybody else get 28?
Yeah.
Very good. Alright, next we needed to find LO. Who wants to tell me what they got for LO? 13. Everybody good with that? And then last, measure of angle NML equals how much? 74 degrees. Why did we not have to subtract that one? No.
Because it's opposite angles.
Opposite angles. Very good. Opposite angles are congruent according to our property on the previous page. Okay, next one. WXYZ is a parallelogram. Find YZ and the measure of angle Z. So before we can find a side or an angle, what do we need to find? A and B. So how are we going to find A? Set them equal. Good. Opposite sides are congruent. Okay. So we solve this. Move the A. Move the 4. What are you guys getting for A? 7. Good. Everybody good there? What can we do with that A now? Plug it in for what side? YZ. What are you guys getting for YZ? 52. All right, now we need to solve for B. What am I going to do with the two B binomials, Aiden? Good. Consecutive angles are supplementary, so we're going to add these two up. And set equal to 180. What are you guys getting for B? 7 again? Oh, look at that. Didn't realize I did that. Alright, so what can we do with B now? Plug it in for angle Z. So 9 times 7 plus 2. How much is angle Z? 65?
60. Yeah, 65.
Any questions on that one? Speak now or forever hold your peace. Alright. Okay, next one. EFGH is also a parallelogram. We need to find JG and FH. Before we do that, what should we figure out? Z and W. And what do we know about the diagonals in here? Good. They bisect each other, creating congruent segments. So what are we going to do with each of the little pieces? Set them equal. What are you guys getting for Z? 4.5. Can we leave it as 9/2? How much does W equal? 4. All right. JG. What do we plug in for JG? 4 plus 8, which is 12. So that's an easy mental math there. And then FH, what are we going to need to do with that? There's a couple different ways you could do FH. Good. Plug it into one of them and then multiply it by 2, double it. Okay, so I'm going to plug into JH. 2 times 9/2 is how much? 9. Good. The 2's cancel, so that gives you 9. So then FH is double that segment, so you should get 18. Any questions there?
Oh. Because it's just JG and 44.
All right. Okay, let's flip it over. More properties. More properties. All right, conditions for parallelograms. So this kind of works you backwards. So first one says if one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram. Okay, so if you're coded an opposite pair of sides congruent and that same opposite pair of sides parallel, then you can say that's parallelogram. Yes. Then you could add all your other coding. Yes. All right, next one says if both pairs of opposite sides of a quadrilateral are congruent, we have a parallelogram. So if you've got opposite sides coded congruent, I can say that's parallelogram. And if both pairs of opposite angles of a quadrilateral are congruent, then you can say it's parallelogram. So if you've got this coding, you can say parallelogram. And the last two, if a quadrilateral says the consecutive angles. So if we've got an angle measure here, and then an angle measure next to it, that's 180 minus it, and an angle measure on the other side next to it, then I can say that's a parallelogram. So if you've got one angle that's consecutive angles are supplementary, parallelogram. And then lastly, if you have a picture, a quadrilateral that has diagonals drawn, and the diagonals are coded with bisecting marks, then you can say that's parallelogram. So to bring it home one more time in case you need just a quick look somewhere for the vocab, these are your 6 properties of a parallelogram. So they just repeat everything we just did in all the theorems. Okay? All right. The whole point of knowing those 6 theorems, or not theorems, those 6 properties, is because this is what you're going to be tested on. You're going to be given figures. They may not look like parallelograms, and you're going to be asked to name it, okay, and justify your name. So you have to know the properties to be able to write down the justifications. So it says, determine if the quadrilateral must be a parallelogram. So we look at this first one, and we've got 6 properties we need to think about, and which one of those properties would help us determine if that's a parallelogram.
They're supplementary.
Good. So we have one angle that's supplementary to both of its consecutive angles, correct?
Yeah.
So that may look like a square, but according to its property, it's a what? Parallelogram. Okay, so question says determine if the quadrilateral must be a parallelogram. So we write parallelogram. So we name it, and then we justify because, and you write down your property you just used. One angle is supplementary to its consecutive angles. So that's why you have to have these properties known. And I'm going to say, I don't like using the word memorized on this one because you have to understand the properties. You have to visually see them. So you can't just memorize what the words are. You have to understand how to visually identify them. Okay, so parallelograms have 6 properties. We're going to go into all the other figures on that diagram that have more properties. So by the end of this, you're going to have like 15, 20 properties. Okay? All right. So this next one, B. Based on the coding, the properties on there is a parallelogram.
No.
No. Why not?
It's a trapezoid.
Okay, good. We haven't talked about trapezoids yet, so I can't use that. Okay, not yet. But I know it's not a parallelogram. I would agree with Hayden. I want you guys to try and figure out which property would tell us why. Go. Talk, look at your properties, figure out which one. All right, what do you think? Yeah?
It's the the one where I don't know how to describe it. It's just in one.
Just say the property, like you said.
If one pair of opposite sides of a quadrilateral are parallel and congruent, then the quadrilateral is a parallelogram.
Good. So one pair of opposite sides must be both parallel and congruent. So you've got a parallel marking, you've got congruent markings, but in order for it to be a parallelogram, it's got to be on the same set of opposite sides. Does that make sense? Okay. All right, C. What do you guys think? Parallelogram, not a parallelogram? Thumb up for parallelogram. Thumb down for not a parallelogram. Okay, this one is a parallelogram. This one's a little trickier.
I second guess because it didn't have a congruency symbol in the middle, but it's still true.
Okay, but it's because of, okay, the third angle theorem we learned. Okay, so we learned this. We know that if two angles are congruent in a triangle to another two consecutive angles in another triangle, then by the third angle theorem, that third angle is also congruent. So if we know that, then we know opposite angles are congruent in here. So therefore, opposite angles are congruent. Okay, so we have to state that third angle theorem first, because without that missing angle piece, we would not be able to say that it was parallelogram. All right, last one, D. What do you guys think? Parallelogram, not a parallelogram? Someone besides Aiden this time. How about give me thumbs up, thumbs down? Thumbs up for parallelogram, thumbs down for not a parallelogram. Okay, I'm seeing mostly, if not all, not a parallelogram.
Sorry, I was putting a thumbs down.
Yes, Aiden?
If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is parallel.
Good. So both pairs of opposite sides have to be congruent.
And
Right now, the pairs of congruent sides are what? Consecutive. Okay, so these are consecutive sides congruent, not opposite sides congruent. So we would say both pairs of opposite. I always like to kind of uppercase, capitalize my key form, like the key point of why it's not. So both pairs of opposite sides must be congruent. So we've got two pairs of congruent sides, but they're consecutive. They're not opposite of each other. So that's where we go wrong. Okay, any questions?